So we're now going to talk about an interesting case study called the ImageStreamGang, and we're going to demonstrate the use of Java parallel streams in support of the implementation of the ImageStreamGang. And then we're also going to show how you can integrate this with Spring in order to be able to run the test and get the results. So that'll be the last thing we'll talk about. So we're going to start off by talking about the structure and functionality of this app, which you can get at my GitHub repository. And there's actually a whole slew of concurrent and parallel frameworks that we show in this app. One of them is the parallel streams version, and that uses the common fork join pool. There's also a completable futures version, which we'll talk about later in the course when we talk about completable futures. And then just for good measure, there's also stuff in that shows off various reactive streams frameworks like RxJava and Project Reactor. We won't talk about those at all right now, but we'll come back at the end, towards the end of the class, and talk about them too. So the basic idea here is this allows you to combine streams and completable futures and reactive streams with something called the StreamGang framework in order to download, transform, store, and display images in parallel. And there's an Android app version of this, there's a command line version of this. They all do essentially the same thing, just use different GUIs to do that stuff. Let's just look for fun at the Android app version because it's a bit more visual, but you can get the same effect with the command line version. So in this case, you prompt the user is prompted for a list of URLs that you want to download, and then the user provides that list, and then we click the download button. This should look very familiar because it's kind of like your web crawler example, and it goes out and it downloads those images, and then it applies a bunch of image filters to transform the images that have been downloaded. Like in this case, we have simple filters like a null filter and a grayscale filter and so on. And those results are then stored in persistent storage on the local computing device. And then the results are displayed so you can see what they look like. There's a whole bunch of cool modern Java features in here, including Project Reactor and completable futures and so on. So we're going to talk about parallel streams right now. And you can see that I apply that little trick we just talked about in the previous lesson about using reduce here instead of using flat map. So we use map and reduce instead of using flat map because it works a heck of a lot better, as you'll see. There's also a completable futures version that we'll take a look at when the time is right. And throughout the client application, if we're looking at Android in particular, there's a whole bunch of cool foundational Java functional features as well, just showing you can use functional programming with modern Android as well as with server-side stuff. So because I'm a big fan of software patterns, there's a bunch of patterns from the classic Gang of Four book, which hopefully you've been exposed to in other classes, and other patterns from the Pattern-Oriented Software Architecture book series, of which I'm a co-author of 3 of 5 of those. Some of the patterns are very essential to the design of the application. So, for example, everything that uses streams is an embodiment of the so-called pipes and filters pattern. And the intent of this pattern is to take an application's task and break them up into a bunch of other smaller tasks, call them subtasks, I suppose, and then have those tasks or subtasks connected together using pipes, and then information flows through those pipes and it gets transformed as it flows through the pipes. So that's basically what you got, of course, with Java streams. Other technologies also do something like that too, like pipelines that you might find with the Unix or Windows command shells. There's also a pattern called future, where you get a proxy when you invoke an operation. Rather than blocking, waiting for the operation to complete, you get back something called a proxy. And then when the operation completes, you can obtain the results. And that is what's used with the completable futures framework, which we'll talk about later. There's also a pattern from one of the books, I think it's the POSA 3 book, which is called resource pool. And this is essentially a way of pooling resources that are expensive to create, like threads or connections and so on, so you can recycle them without having to shut them down. You just put them back in the pool, and when you need them again, you grab them out of the pool. So that's a nice optimization pattern. There's also a pattern from the Gang of Four book called the template method pattern, where you define the overall structure of an algorithm in a method, and then you let subclasses come along and override some of the so-called hook methods in the class that the template method uses to carry out its processing. And that's a way of being able to try to get as much systematic reuse as possible while still being able to customize and tailor some pieces of the algorithm as you see fit, as the need arises. And then, of course, another pattern that's used absolutely everywhere is the factory method pattern, where you abstract away from the details of how you create objects and make it easy to modify the creation steps without changing the clients that use whatever is created. There's another method, or another pattern rather, called decorator, which allows behaviors to be added dynamically to objects without affecting the behavior of other objects from the same class. And we use this in a very clever way for the image filtering algorithms that we apply. And then we also have singleton, which is perhaps an anti-pattern, but I like to use it for a few very isolated things, typically processing of command line options. That's my favorite thing. There's also another pattern that's applied here, which appears in some of the POSA books, called command processor, where you basically take some piece of functionality, some kind of service, and you bundle it together in an object, and then you can pass that object around and have that object executed in different threads of control. So the thread that runs the object, runs the service on the object, is not necessarily the thread that creates the object in the first place. So this is used for lots of concurrent processing, and it's very important in Android because things that run in the main thread, the user interface thread, can't block. So you often run computations in the background, in a background thread, and when they're done, it then passes the command containing the results of the long-running computation that might have blocked in the background to the user interface thread where it can be displayed. So as you'll see when we look through this example here in a minute, there's a lot of classes. There's probably 24 classes here. And so we look at this from a couple different perspectives. So we're going to look at it from a pattern perspective. We looked at some of the patterns here. We'll look at some more of those. We looked at from a kind of a flow of the data through the system perspective. And then ultimately, we're going to look through the code in some detail. So not a bad idea to go back and rewatch these videos if you really want to see how this all works. Something else we're going to do is we're going to visualize how things apply in the context of streams. I love to visualize stuff, so this will help you to see kind of the big picture of what's going on as data flows through the different stages. But ultimately, you have to read code at some point, so that's a good thing to get in the habit of doing as well. Okay, so that's an overview of the ImageStreamGang case study. We will now start looking at it in more detail and see it from different perspectives.